Hello everyone, I am Dr. Jyoti Mandala. Welcome you all to the video lecture series on the course operating system. Let us continue what approach to be followed to detect whether our system is in deadlock or not. In our last video, we understood if the resources are of single instance, how this wait for graph can be used to detect the deadlock. Now in this video, we will be understanding how can like this banker's algorithm can be used. This banker's algorithm is used only when if you have multiple instances of your resources. Like if you have one printer, then it is of single instance. If you have 10 printers, then it is called as multiple instance. Okay. Now, what actually this deadlock detection is, when a process requests for any resources, then the request will be granted immediately. Then after granting the request, the operating system will check if there is any deadlock has been occurred or not. How it will be checking that one? By using these deadlock detection algorithms. It can be wait for graph or banker's algorithm depending upon the number of resources. Now, if the deadlock has been detected, then we need to use the recovery algorithms to remove the deadlock. Now, how the recovery approaches can be used, that we will see in the future classes. But in today's video, we will see how this banker's algorithm can be used to detect the deadlock. Alright, the algorithm approach is very simple. It will be using some data structures like work. It will be using some data structures like allocation, which tells like how many resources has been allocated for certain set of processes, and request what resources they are requesting and how many available resources are there. Okay, the algorithm approach is very simple because while learning the deadlock avoidance, you have followed one algorithm. This also looks similar to that one. So let us make a note of all these steps here. Then we will see how can this is the first step where we need to take one variable called work and the other array called finish. Depending upon the size of processes, we need to take array size of finish like this, and then um, we need to set all the values to be false depending upon the allocation. If the allocation is not equal to 0, then finish has to be made false. If the allocation is equal to 0, then finish has to be made true. Okay, simple terms, if it is not equal to 0, finish is false. Okay, now second one is, if we need to take first process, and if its finish is false, then we need to check its request is less than the work or not. If its request is less than the work, then we need to uh, update the work, like what are all the requests it has asked, that has to be allotted. And once the execution is done, it will be releasing the resources, and those resources will be added to the work again. So whatever allocation is done, that has to be added back to the work, and its finish has to be turned to true. Now finally, if we could able to find out the finish of all the processes as true, then there is no deadlock. But if a particular process finish is true, then that process is in the deadlock. All right, so let us what we will do. Let us take one example first, and then we will apply this algorithm and understand how it is working. Okay, so to understand this one, what I will do, let us take five processes: P0, P1, P2, P3, P4, five processes. Let us take as an initial thing. This is an example, and let us take three resources, A, B, C, and A is of 7 instances, B is of 2 instances, and C is of 6 instances. Let us consider. And let us consider at a particular time period, let us consider at a particular time stamp of T naught, uh, the processes has been allocated in this particular way, and their request is like this, and at that particular time the available number of resources are like this. Okay, let us consider this, and then now let us try to apply this banker's algorithm and see whether our system is in deadlock or not. So this banker's algorithm will help us, whatever is mentioned here, this algorithm will help us in detecting the deadlock. This is our banker's algorithm. Okay, now what we will do, the first step is we need to take one variable called work, and let us try to solve this approach now. Okay, what we will do, okay, so we need to take work variable. So take work variable is equal to your available. What is available here? 0, 0, 0. So work has been now changed to, now the value is 0, 0, 0. Okay, now we need to take another variable. You can see here finish variable, which is of size, what n is nothing but number of process. We have 5 processes. So let us take 5 processes array for finish. Okay, so 0, 1, 2, 3, 4. This is 0 process, 1 process, 2 process, 3 process, 4, and this is for finish. And how the finish initial values are set, we need to check the allocation of 0, allocation of 1, 2, 3, 4 process. If it is not equal to 0, then it should be false. You can see allocation of none of the process is equal to 0. All are not equal to 0 only. So initially they are made to false. Okay, if after going through this algorithm, if any process has left with false itself, then that process is in deadlock. Okay, all right. Now let us go with the second this step. We need to select one process. So let us take our process P naught first. We will let us go in the order. Now what we need to do, its finish of I is false only, yes, and its request. What is its request? 0, 0, 0. Its request is 0, 0, 0 is less than or equal to work. What is less than or equal to work? Work value is also 0, 0, 0, which is true. So as it is true, what we need to do? It its request is 0 in this case, but if it is different more than 0 value, then we need to allocate those resources and we need to finish that task. And then what happens, we need to go with this third step where work, what is work? 0, 0, 0 plus what is allocation of 0? Allocation of 0 is 0, 1, 0. 0, 1, 0 is to be added to the work, and that work has to be updated. What is this now? 0, 1, 0. So the work has been updated to now 0, 1, 0. Got it? Okay. That means now P naught has completed. It has to be converted to true. That is our next step. Now after that, we need to go back to the step 2. We need to find out the second process that is called P1. And P1, what is the finish of P1? It is false. Now take the request of P1. What is request of P1? 2 not 2. So 202 is less than or equal to work. What is work? 010. Is it true? No, it is false. So in that case, it has to wait. It is not completed yet. It has to wait. We can come back later. Now let us take the third process P2. What is P2? P2 request is what? 000. Okay. 000, which is less than or equal to 010, which is true. Then what we need to do? The work value of 010 plus its allocation. What is its allocation? 303. 303 is to be added to the work, and the work has to be updated. Now what is the work now? 313. Right. So the work has been now updated to 313. Okay. Okay. Now let's move to the next one. P3, let us take. What is P3? P3 100 is less than or equal to what is work? It is 313. So let us take 313 and it is true. So now what we need to do? 31, um, work 313 has to be added to P3 allocation, that is 211. 211, and the work has to be updated. What is that? 3 plus 1 is 5. 1 plus 1 is 2. 3 plus 1 is 5. So 525. So this has been now changed to 525. I hope you all could able to understand. Now, sorry, parallelly I have to change this one to true, and now we are taking P3. It is also true. Now go to P4. What is P4? P4 request is 002, which is less than or equal to work is 525, which is true. Then in that case, what we need to do? The work value is to be added to the allocation of P4. What is that? 002, 002, and the work has to be updated, which is our step 3. Okay, now what is the value? 527. Are you all understanding? So now this has been updated to 5. I will write here 527. Okay, now P4 is also completed. Now any process is left, P1 is left, this is left. So we will come back to P1 again. So P1 let us do. What is the request of P1? 202, which is less than or equal to 527, which is true only, right? Now what we need to do? That 257 has to be added with the allocation of P1. What is that? 200. Sorry, 217. I think somewhere did I do wrong? Did you see here? P3 value is 211. I have done wrong here. Did you see? So here it will be 4. I hope you all could able to see. So it is 4. Now 254, it is 254, okay, is to be added with 002, 520, 526 it is. Okay, so 526. Now this 526 has been taken here. Okay, so 526 plus, and then what is the allocation of P1? 200. Okay, now add this one, 7, 2, 6. So finally we have 726, which is the original value of the allocated resources, and P1 also completed. Now you can see for all the resources it has become true. That means the system is not in the deadlock, no deadlock. Okay, that means there is no recovery algorithm is required. But for some other example, if you take, there may be a case like, let us consider one process among five. Let us consider P1 is false, false only. Then in that case, we can tell P1 is in deadlock and remaining all other processes are not in deadlock. If that situation occurs, then we need to go with the recovery algorithm. That we will see in the next video. I hope you all could able to understand how this Banker's algorithm helped us in finding or detecting whether our system is in deadlock or not. Let us all meet in the next lecture. Until then, thank you all of you.